Photo Brussels 1927. Until now, classical physics explained practically everything. From here on, classical physics was unable to explain practically anything. Quantum mechanics would now prevail. Transition from classical physics to quantum formalism within the framework of the cosmic unification model. Up to approximately 1941, classical physics provided a coherent and largely sufficient explanatory framework for the understanding of natural phenomena. Within its domain, the structure, dynamics, and interactions of physical systems could be interpreted in a consistent and intuitive manner, grounded in observable reality. Beyond this point, however, classical physics began to be regarded as insufficient to account for emerging experimental results at the microscopic scale, leading to the progressive dominance of quantum mechanics as the prevailing theoretical paradigm. On the virtues and limitations of mathematical formalisms. Within the present model of cosmic unification, mathematics is understood as a descriptive language, precise, powerful, and indispensable, yet not intrinsically truthful by itself. Mathematical formalisms express truth only insofar as they faithfully correspond to the physical structure and functional reality of the cosmos. When such correspondence is absent, mathematical constructions may still retain internal consistency, but they cease to represent physical truth and instead become abstract artifacts detached from nature. This distinction is fundamental and, in many cases, insufficiently emphasized. The central issue arises when mathematical formalism precedes physical understanding. If the underlying physics is not first comprehended in a clear, global, and structurally coherent manner, it becomes impossible to construct a mathematical framework capable of accurately describing, measuring, and predicting the behavior of natural systems across cosmic scales. From this perspective, the current difficulties encountered in quantum physics become more intelligible. Many rigorous and intellectually honest researchers continue to question why quantum formalism proves so resistant to direct physical interpretation, particularly when applied to the structure and dynamics of the cosmos. Within the framework proposed here, this limitation is not accidental but methodological. Over centuries, classical physics accumulated a vast body of empirical and conceptual knowledge rooted in observable reality and structural coherence. However, in the transition toward quantum mechanics, much of this accumulated experience has been undervalued or set aside. In its place, highly abstract and often individualized mathematical formalisms have been developed, in many cases without a sufficiently grounded physical basis. As a consequence, a conceptual inversion has occurred. Instead of deriving mathematical descriptions from physical reality, there has been a tendency to require that physical reality conform to pre-established mathematical structures. This inversion leads to interpretative difficulties, conceptual paradoxes, and the persistent gap between formalism and physical intuition. The model of unification of cosmic levels seeks to restore the natural order of this relationship. Physics, understood as the structural and functional reality of the cosmos, must guide and constrain mathematical formulation. Only under this condition can mathematical language fulfill its true role as a faithful representation of nature, enabling a coherent and unified description of both the microcosmic and macrocosmic domains. To this end, this model of unification of cosmic levels provides new elements and basic explanations of cosmic structure, compatible with an intuitive and logical development of the microscopic or atomic world as well. For example, it explains the gravitomagnetic forces that construct orbital systems at all scales, atoms, stars, galaxies, etc., and the architecture of orbital systems in which charges are located in electromagnetic fields and their peripheral orbits. Therefore, electrons cannot collapse into the nucleus because it is precisely the orbits, with their electropositive potential, that attract, capture, exchange, and hold them. In other words, electropositive charges are not properties of nuclear matter, but rather of the peripheral electromagnetic fields and orbits. Therefore, electrons circulate toward these fields and orbits, where they are compelled to remain in order to compensate for and cancel the positive charges of these atomic orbits.